So we are going to use IntelliJ and we are going to create one Kotlin project. Let's say Kotlin underscore DSA. Okay. We'll use this project to solve our data structure problems and we'll just finish this project. We are going to use Kotlin throughout our data structure problem solving series. Okay. And in today's video, as we are implementing stack, let's create one package stack. Okay, and now the most important part, what functionality our stack implementation is going to have. So our stack data structure should allow us to add some item into our stack. Then we should be able to remove some items from our stack. We should be able to calculate our stack size. We should be able to get to know the topmost element inside our stack at a given time. We should be able to check that if our data structure is empty or not. Now, as an Android developer, if someone gives you a new requirement, what is the first step you are going to do? You will create one interface and you will write the functionalities you need later on. And then later on, we will implement these functionalities. Okay, so let's create one interface. Okay, and this interface we will name it as our stack. Okay, one interface is created. This is our implementation, what we need inside our stack. Now we need to specify that what type of element our stack can hold. So let's specify type T of any type. Our stack is going to support any kind of variable. Any kind of element or data you add, integer, float, our stack should be able to handle it. First functionality we need is, we need one method using which we can add or insert some element inside our stack. So we created one method called push, and this will take one parameter. User should be able to pass one element of type T. Any type of element can be added inside our stack. Okay. Then second function we need to remove some element. So that we are calling it as pop. And this function will return us an element, the topmost element which is remaining inside our stack. Now there is a corner case as well. Our stack can be empty in some cases. So this element can be null as well in some time. So let's make it nullable. Okay. So we have two functions. One function to insert some element inside our data structure implementation. Another one to remove some item from our stack. Now let's start implementation for our stack interface with these two minimum function at first. We will add more functions later on, but for now let's start implementing our stack with only these two functions. Now to implement these functionalities, we are going to create one class and we are going to name it as our stack implementation. Okay, let's minimize this and let's open this right side. Okay, so as our interface is telling us that our stack should be able to handle any kind of data, so we need to add the same thing inside our class as well, that our stack can take any kind of data. Okay, then we need to implement this interface. Okay, so we are implementing this and this will take data as T, which is coming from this class. Now we need to override these methods, but before that we need to add one storage inside our stack. So let's create one storage variable. We can use array list, as inside our array list insertion and deletion can be done using big O of 1. So we are going to create one array list of T, any type of data it can hold. Then we should be able to showcase our stack at a given point of time. One string representation of our stack should be there. So we are going to override this method to string. Okay, but we are not going to use this syntax. We are going to use a string builder. So we can just use build string, this one. Okay, and inside this, first we are going to use this append line. So we are going to add one line top element, or maybe top of a stack, let it be there. Then we need to print the items from our storage. So we are going to use this storage variable. In this, all of our stack variables will be there. So we need to print this also when someone calls this toString method on our stack. Then we will be using this reversed function. Why? Because the last item someone insert inside our stack, that should stay on the top. So inside string representation also, whatever the item is pushed in the end, that should be on the top. Okay. Then inside this, we will use this for each method, and we will use this append line. And inside this, we will just take element it. This is coming from this for each. Okay. Then once we added all the element inside this string representation, we will just close our stack string representation with one empty line. Okay, like this. This is our string representation. This is the place where all the items will be stored inside our stack. Now we need these functions. So we can just override this method, and inside this push element, the simplest thing we need to do is we need to add this element inside this storage. Okay, so we can just take this storage dot add, and we are going to add this element. Now we need to add this pop method implementation as well. So inside this pop function, we need to remove the topmost element from our stack. So first we need to check, is our stack having some items or is it empty? So we'll check if storage dot size is equal to 0. Okay, that time there is no item present inside our stack, so we can return null. Else, if our stack is having some valid items, okay, then we need to remove the topmost element from our stack. So we will take our storage dot remove at, and we need to remove the last element from our storage. So we will just take storage size minus 1, the last element. Let's say our stack has 1, 2, 3, 4. So when we want to remove the element, we need to remove this. Okay, this is the last inserted element, so we need to remove this. Now we need the index of this. Okay, so how we are going to take? Index start at 0, 1, 2, 3. So we will take size minus 1. Same thing we will do here. Storage dot size minus 1. Okay, this we need to return. Alright, we can make this storage object as private, and our stack implementation is ready. We have one place where we can store the items. We have our stack string representation. Then we have one method to add or insert element inside our stack. We have one method to delete items from our stack. Okay, let's go back to main class. Now if we want to create a stack, we can just use one variable stack, and we can use our stack implementation, this class. Let me open this on right side. Okay, we can use this class object. Okay, and we are going to create one stack of integer first. Okay, so we have specified this type as integer. This is the simplest representation where we have created one object of our stack representation. Okay, so our stack object is ready, and let me open our implementation class as well in the right side. Let's resize it a little bit. Alright, now if we want to push these elements inside our stack, we can just use stack dot push method, which we have implemented already, and then we can push the first element, and similarly we can push the next element as well. Okay, so we have 4 elements, and we have pushed all of these 4 elements inside our stack object. Now we can use this println method to print our stack state, And as we have already implemented this toString method inside our implementation class, this will print beautifully. Let's run our program and let's see our stack current state. So this is our stack right now. Okay, this is the current state of our stack. Now let's see how the code executed line by line. Okay, so when we push the first element, this 10, at that time our stack was looking like this. Then we pushed next element and our stack was looking like this. Then we pushed these two elements as well, and then finally this is our stack. Okay, we can also use pop method to remove some element from our stack. Okay, so right now we have 4 element. Let's try to use stack dot pop, and this method return one element. Okay, so let's try to store this in a variable called removed element. Okay, let's add one print statement and we are going to use the same variable. Removed element is this, and after removing one element, again let's print our stack object. Okay, let's run our program again. We have 4 element at first. When we pushed 4 element, we have the same 4 element. Then we did stack dot pop. So the topmost element 40, this is popped out from our stack. So this is showing the same in print statement that removed element is 40, and then we are printing our stack again. So then after removing 40, this is the stack we have right now, and right now 30 is at the top. But we don't have any method yet to find out the top element from our stack. Okay, so let's go back to our implementation class and let's go back to our interface. Let's add one method peek. Okay, and this will return us one element, and this can also be null if our stack does not has any element. So this peek method will be responsible to return us the topmost element from our stack at any given time. Now let's implement this inside our stack implementation. So we are going to just take this peek method here, and to give the topmost element we need to return from this storage. We are going to take the last element. Okay, so we are going to take storage dot size minus 1, the same way which we was using while deleting from the top. So let's say we have these 4 element. Okay, so if you want to take the topmost element, this is the topmost element, right? So we are just taking from our storage size minus 1. So we are taking this last element and returning it as the topmost element. Now let's add one more function. If we want to check what is the size of our stack, okay, this will return as integer. We can implement this function as well, and inside this size function we are going to return the size of our storage. Okay, we are storing all the items here, so we are just returning the size of this. Okay, suppose we want to check if our stack is empty or not, so we can add one more method is empty, and this will return us a boolean. We can implement this as well inside our stack class, and we can just check storage dot is empty. If storage is empty, this method will return the respective value. Okay, let's add one more print statement. Stack size currently is, and we are going to take from this object size. Same thing we are going to add here as well after removing one element from our stack. Let's add one more print statement. Top element is, and let's create one variable to find out the top element. Okay, how we can find out? With the help of this peek method. Okay, so we are going to take stack dot peek, this one, and then we can use this as a top element. Let's add these top element statement after removing some value also. So let's say top element now, and we use this. Let's run our program now. Okay, so let's verify how our stack is performing. So we created one stack object, we pushed 4 element. Okay, then we are printing our stack. Okay, so the first state is this, we have 4 element, then we are printing current size of that stack. So at that time 4 element are there, then we are checking top element, So it is showing top element is 40. So this is working fine. Peak functionality is working fine and size is also working fine because we have 4 element itself and 40 is at the top. Then we did stack.pop. So it is showing this print statement. Removed element is 40, which is correct because at that time 40 was at the top. Then we are printing our stack again. So there are 3 elements, which is fine. Then we are printing the stack size as well. So it is showing stack size is 3 because we have removed one element. And then the top element is showing 30, which is correct. So our stack implementation is working fine. All of these methods are working fine. So our stack implementation is working fine, and this way we can implement stack data structure in Kotlin. We have implemented all of these functionality inside our stack data structure. I hope you like this video. If you enjoyed this video, please like, share and subscribe to my channel. In the next videos, we are going to use our stack implementation and we are going to solve multiple lead code problems which can be asked in data structure interviews. So stay tuned and do subscribe to my channel. I will see you in the next video.